Okay guys, so I'm here to tell you about the mean value theorem today. So before we actually talk about what this theorem is, let's kind of build the intuition. So let's say I go out for a jog and I just run for 1 hour, and in that hour I run 10 miles. So, pretty decent pace. But here's a question. If I run 10 miles in that hour, does there have to be a time where I have a speed of exactly 10 miles per hour? And the answer, of course, is yes. Because if we think about it, right, if I run 10 miles an hour the whole time, then yeah, I'm always running 10. But if I start out below 10 miles an hour and later go above 10 miles an hour, there had to be some point in the middle where I was running exactly 10 miles an hour, as long as my function is nice, for example. So here's what the mean value theorem says. If f is differentiable, if you don't know what differentiable means, go ahead and go back and rewatch the previous video. So if f is a differentiable function and also a continuous function, it's a little redundant because we know it's if it's differentiable, it's got to be continuous. If it's differentiable continuous on the interval from a to b, there must be another point where x equals c on the interval a to b with f prime of that c, so the slope at c equaling the average slope f of b minus f of a over b minus a. So, okay, so here's what this is saying. If you have a differentiable function and a continuous function on some interval, there has to be a point c in the middle where the slope is equal to f of b minus f of a over b minus a. Okay, so what this is saying this is our instantaneous rate. And then this is our average rate of change. So there's got to be some point in time where the instantaneous rate equals the average rate of change, is what it's saying. If my average rate was 10 miles an hour, there's got to be some time where my instantaneous rate was 10 miles an hour. Or, in graphical terms, there's got to be some point where the slope of the tangent line equals the slope of the secant line. Okay, so what's kind of going on here is if you were to draw like a little graph here. Okay, so let's draw a graph here. Here's some f of x. Here's your a, and here is your b. So if you were to take a straight line, draw a secant line between those 2 points, the mean value theorem doesn't tell you where it is, but it tells you somewhere in the middle, there has to be some point where the slope of that tangent line is parallel to the slope of the secant line, where those slopes are identical. That's the same. There has to be some point C. Not necessarily where it is, but there has to be some point C. Okay, so let's go ahead and talk about like a couple of quick examples here. And then we'll kind of try and build up some intuition for this. So another thing, right? Say you get in your car, you drive 60 miles in 1 hour. There had to be some time where you're going exactly 60 miles an hour. So let's, for example, see this. Find the C that satisfies the mean value theorem, which I'm going to abbreviate as MVT, on f of x equals ln of x plus 1. So there's your function on the interval from 0 to 3. Okay. So when we do that, we're saying this is the a and this is the b. You're trying to find the c. So what does that x value equal? So setting up my equation, what is the point where f prime of c equals f of 3 minus f of 0 over 3 minus 0? So of course we could plug in this function. F of 0 is ln of 1, which is 0. F of 3 is equal to ln of 4. So there has to be some point where f prime of c equals ln of 4 minus 0 over 3. Now what is f prime, right? F prime, we can look at this function, and we can find f prime. So my f prime here is 1 over x plus 1, chain rule times 1. So we're saying 1 over x plus 1 equals ln of 4 over 3. Now, we could solve this in a couple different ways. We can like cross multiply, for instance. You could just flip both fractions. So 3 equals x plus 1 times ln of 4. So 3 over ln of 4 equals x plus 1. So x equals 3 over the natural log of 4 minus 1. Okay, so that's just doing some algebra. The important part is this, is saying, like, I'm going to set my f prime equal to that average rate. And then once I have that f prime, I need the equation for f prime, but then I'm just doing some algebra to try and solve that out. So that's how I can find the c. So that's one case where the mean value theorem is. Here's like another example of where you'll see the mean value theorem. So suppose I give you a table of data. So suppose I say here's x, here's f, and x goes 0, 1, 2, 3, 4, 5, 6, and you go 2, 4, 5, 2, 0, negative 1, 0. And I'm going to ask you this question. At least, how many times must f prime of x equals 0 on the interval to 0, 6, given that f is differentiable? Okay, so at least how many times must f prime equal 0? So what that's saying is we're saying that like that slope equals 0. So that f prime, which equals the f of b minus f of a over b minus a, that average rate of change equals 0. So what we're going to do is we're going to look for intervals with an average rate of 0. So I'm going to see where is the interval where you have an average. Okay, so we go 2 to 2, right? So I start at 2 and I go back to 2. I go 0 to 0. I start at 0, I go back to 0. So somewhere in between those, because this is a differentiable function, there has to be a point where the slope is 0 between each one. So here's how you set this up. So we see like once in 0 to 3, once in 4 to 6. So to answer this question, we have twice. We have the interval from 0 to 3, and again on the interval from 4 to 6. And this is because there has to be some point where f prime of c equals f of 3 minus f of 0 over 3 minus 0 equals 0 on the interval from 0 to 3. And there's another one on the interval from 4 to 6 where your f prime of c equals, again, your f of 6 minus f of 4 over 6 minus 4, which again is 0. So that's kind of what you're looking for when you're writing this kind of thing up. And I also forgot to mention, this is because f is differentiable. So I made sure I answered the question. I said, okay, twice, here are the 2 times it happened. I showed that it happened because it's differentiable. Like, it's good to set this stuff up. And if I ask, like, is there a point where the slope equals 2? Then you say, okay, I'd find an interval with a slope of 2, and then I would say, well, that happens on the interval from 0 to 1. Okay, you can also see this if you plot the points, right? If you were to plot these points, you say, okay, my function starts at 2, 4, 5, 2. Like, if it goes up and then comes down, there has to be a point in the middle where it has a slope of 0. And then again, it goes down and then back up, so there's got to be another point where it has a slope of 0. Maybe there are more, but there have to be at least 2. So graphing the points can help you build an intuition. But definitely just think about, like, where are these intervals where it's the same on both sides. So that's how you do that problem. One thing I wanted to note is that f must be differentiable. If your function is not differentiable, the mean value theorem doesn't apply. So if not, like, let's say you have an absolute value type graph, something with a sharp corner, right? So if I pick 2 points, say on that side and that side, the average rate of change there, that average rate is 0. But if we look at this, there's no point here where your f prime equals 0. But this doesn't contradict the mean value theorem because it's not differentiable at x equals 0. So that's one way you can kind of get out of that. Because this function is not differentiable, there's no point where you have a slope equal to 0. Okay, so that's the mean value theorem. I want to remind you, this is not the intermediate value theorem. So this is not the intermediate value. The intermediate value theorem had nothing to do with slope. The intermediate value theorem just says this, like, if f is continuous, not differentiable, it just has to be continuous, and say like f of a equals 2 and f of b equals 10, f goes through every value from 2 to 10 on the interval from a to b. So all that's going on there is just saying, we're just talking about values of f. There's no slope involved, there's no derivative, it's just talking about continuous. If your function goes 2 to 10, it goes through everything in the middle. Okay, so that's something just to make sure you can keep those clear. Mean value theorem kind of deals with slope and that sort of stuff. Okay, hope this helped, and I'll see you guys soon.